All right, everybody. Today we're going to be learning lesson 2.2 on creating and solving equations. The homework associated with this lesson will be on pages 51 to 53, 2 through 20 even. And basically in this lesson, they're going to give us various problem-solving situations that we would be able to write an algebraic equation with a variable for and solve for that variable to answer the question. So we're going to start out fairly easy with some pretty basic, straightforward problems, and then we're going to work our way up to more difficulty. So here's one that's fairly simple. In this situation, Mako runs M miles each day, and D'Anthony runs twice as many miles as Mako. Altogether, they run 18 miles each day. How many miles does Mako run each day? So basically in this situation, I like to try to figure out what variable I'm going to be solving for, and they've already given us that M should be our variable. So then when they say that D'Anthony runs twice as many miles as Mako, twice as many would indicate multiplication. So we know we're going to have a 2M as well. And then the key word that lets us know what we want to do with those two pieces of our equation is when they say altogether they run 18 miles. 18 is going to be our total, which means altogether tells us add Mako plus D'Anthony, and that should equal a total of 18 miles. So my equation is going to be M plus 2M equals 18. And then we're just going to practice solving that using the steps we already know for equation solving. So we would need to combine like terms, making 3M equals 18. And then the inverse operation of our multiplication here would be division. And so we would get M equals 6, which we would want to finish it out and answer the question, how many miles does Mako run each day? 6 miles would be the answer to our problem, and here's the equation we use to solve it. Okay, so one more that's not too difficult. Bella's cell phone plan costs $18 per month plus 15 cents for every minute she uses the phone. Last month, her bill was $29.25. For how many minutes did she use her phone last month? So in this situation, we sometimes end up with a case where some people are trying to put a variable for months instead of minutes, but that's where you have to look at the question. For how many minutes did she use her phone? So you want your variable to be with the 15 cents per minute. So we're going to have 0.15 M. 18 is what she pays no matter what. And then her total bill was $29.25. So it would be 18 plus 15 cents per month equals a total of $29.25. So then we're just going to go ahead and finish solving that one. In this case, we would need to subtract 18 first. So 29.25 minus 18 should leave us with 11.25, and then we would need to divide by 0.15. So final answer comes out as 75, but we want to make sure we're answering the question for how many minutes did she use her phone last month. 75 minutes would be our final answer. Okay, on this last one we get a little bit more complex. Eric and Charlotte collected donations for the food bank. Charlotte collected 3 times the amount of Eric's donations, minus $20. Eric and Charlotte combined their donations and spent half of the money on canned food. The rest of the money, $50, was donated to the food bank directly. How much money did each student collect? So in this case, we have information about Eric and Charlotte, okay, but we only want to use one variable. So you're going to notice that they never talk to you about exactly how much Charlotte brought. They just say that it was 3 times the amount of Eric's donations minus $20. So we're going to need to represent Charlotte with a variable that relates her to Eric. So when it says Charlotte collected 3 times the amount of Eric's donations minus $20, I'm going to write Charlotte as 3E minus 20. But what we have to keep in mind then is Charlotte and Eric combined their donations. So we want to be careful in our equation that we consider Charlotte is 3E minus 20. But if her donations were combined with Eric's, we need to add an extra E here to represent that this is Charlotte plus Eric, combining their donations. And then they spent half of the money on canned food. So they didn't spend this total, they divided their donations in half, and the rest of the money left over equaled $50. So the question in the end wants to know how much each student collected. So with the equation we have here, we're able to solve for E, or Eric, and then we can use Eric's amount to calculate Charlotte's. So we're going to combine like terms. The 3E plus the E is going to be 4E minus 20 divided by 2 equals 50. And then we're going to get rid of this division on the bottom. If something is being divided by 2, the inverse operation would be to multiply by 2. So I have 4E minus 20 equals 100. We're going to add 20 to both sides to get 4E equals 120. And then we would divide by 4 in the end, and 120 divided by 4 would leave us with E equals 30. So what that means is that we have figured out that Eric collected $30. The question asked for each student, so we need to also figure out Charlotte's collections. So we need to go back to what we originally wrote about Charlotte up here. She collected 3 times the amount of Eric minus $20. So if we now know Eric collected $30, 3 times his $30 would be 90, minus 20 would be $70. So we now have an answer for Eric and Charlotte. I'm going to go ahead and turn to the back side and add some extra things to get a little bit more difficulty going on. We're going to do some examples off of page 47 on the Your Turn problems. So down at the bottom of the page, 47, they relate a little bit of geometry into our problem solving. Down here they have a picture that says a rectangular garden is fenced in on all sides with 256 feet of fencing. The garden is 8 feet longer than it is wide. Find the length and width of the garden. So over here they've shown you to represent that the garden was 8 feet longer than wide. They have a side that says W plus 8 for the length, and they have a side that says W feet for the width. So what we want to keep in mind is when they've told us that the fencing around the sides is 256 feet, they're giving us the perimeter. So on this rectangle, what you need to consider is that when we deal with a rectangle and perimeter, if one side is W plus 8 feet and one side is W feet, we want to remember that the bottom side would also be W plus 8 feet. And the left side would be W feet as well. So if we find perimeter, we're adding up all 4 of these sides, and it should equal a total of 256 feet. The thing that they're wanting us to realize is that we could use distributive property to make this equation a little bit shorter than we might otherwise think. When you look at this, you should notice that you have 2 sides that are W feet long. So the shortest way to write that would be 2W. Plus, you have 2 sides that are W plus 8 feet long. So you should have 2 times W plus 8. And that should equal a perimeter of 256 feet. Now from there, we're going to use distributive property to start this one out. We're going to keep our 2W in front and distribute to get 2W plus 16 equals 256. We're going to combine like terms to get 4W plus 16 equals 256. We're going to subtract 16 and get 4W equals 240. And we're going to divide by 4 to get W equals 60. So we have now found that the width of this garden would be 60 feet. But we also need to figure out the length because the question asked for both. So to get the length, we're going to want to remember that the length is 8 feet longer than the width. So now that we know that the width is 60 feet, we can simply add 8 and figure out that the length is 68 feet and the width is 60 feet. There's going to be some problem-solving situations where you're going to need to use variables on both sides of your equation. So for this, we're going to look at a couple problems off of page 49. On page 49, we have another geometry-related example down here, but this time, what they are showing you is that Claire bought just enough fencing to enclose either a rectangular garden or a triangular garden as shown. The two gardens have the same perimeter. How many feet of fencing did she buy? So the key word in this question is same. We know the perimeter of the rectangle is the same as that of the triangle. So in a math equation, that means they are equal. So we're going to need to set up equations by putting the rectangle on one side of the equal sign and the triangle on the right side of the equal sign to solve this problem. So in our rectangle, we had two sides that were x minus 3 feet long, plus we had two sides that were 3x minus 3 feet long. So this side represents the rectangle. And in our triangle, we had two sides, the left and right side were both 2x minus 1 feet long, but then the bottom side was just 2x. So this is the rectangle, this is the triangle, and we were told in the equation that they were the same, so we put the equal sign in the middle. Now if we solve for x, we can finish the problem. So I'm going to do distributive property, 2x minus 6 plus 6x minus 6. We're going to do the same on this side, 4x minus 2 plus 2x. We now need to combine like terms. So 2x plus 6x is 8x. Negative 6 and negative 6 would make negative 12. 4x plus 2x would be 6x, and the minus 2 will stay there. And now this is why we're calling this a problem with variables on both sides. To solve for x, we can only have x on one side of the equal sign. So I'm going to choose to get rid of this 6x by subtracting 6x on both sides, making this say 2x minus 12 equals negative 2. We're then going to add 12 to both sides to get 2x equals 10 and divide by 2 to get x equals 5. Now what we need to realize is that 5 is not my final answer. All we've done is simply solve for x, and x is not the perimeter of either one of these shapes. They ask how many feet of fencing did she buy, so I need the perimeter of either the rectangle or the triangle. It doesn't matter which we find because the problem told us they were both the same. So you have the option of plugging that 5 back into the side of your equation that represented the rectangle, or the side of your equation that represented the triangle, because either way you'll get the same result. So for this one, let's just do the rectangle side. If I know that the perimeter of the rectangle was 8x minus 12, and I substitute my 5 for x now in there, 8 times 5 minus 12 would be 40 minus 12, or 28 feet would be my final answer for perimeter. So the same thing goes with if I had plugged the 5 into this 6x minus 2, 6 times 5 would have been 30, and subtracting 2 would have gotten me the same result of 28. Okay, so one more time on variables with both sides. Let's take a look at example 8 from that same page. In this case, we have a veterinarian who is changing the diets of two animals, Simba and Cuddles. Simba currently consumes 1,200 calories per day, and that number will increase by 100 calories each day. Cuddles currently consumes 3,230 calories a day. That number will decrease by 190 calories each day. The patterns will continue until both animals are consuming the same number of calories in each day. In how many days will that be? How many calories will each animal be consuming each day then? So in this case, we have two animals. We want them to end up on the same diet plan. So we're going to write where they're starting now and put an equal sign in between. So we're going to start with Simba. Simba is currently consuming 1,200 calories, and the veterinarian is going to increase their diet by 100 calories per day. So I would write that as 1,200 plus 100x. Cuddles, on the other hand, is currently consuming 3,230 calories, and the veterinarian is going to decrease that by 190 calories per day. So the side is for Cuddles. We want to find out when they will both be the same. So we're going to solve by x by getting the x's on the same side. So I'm going to do that by adding 190x to both sides. So I'm going to have 1200 plus 290x equals 3,230. We're going to subtract 1200 on both sides. So it's going to be 290x equals 2,030, and we're going to divide by 290. So that comes out as x equals 7, and in this case, the x that we solved for, 7 means that it would take 7 days for these animals' diets to equal out to one another. So that was part of the question, but the question also did ask how many calories each animal would be consuming at that point. So now that we know it's going to be 7 days, we either need to plug that 7 into the Simba side of the equation or the Cuddle side of the equation and figure out after 7 days how much they would actually be consuming. So I'm going to do the Simba side and say if I did 1200 plus 100x and I now substituted in a 7 for my x, that would be like saying 1200 plus 700. So we know that 1900 calories is where Simba would end up. And because we made sure that that was the number of days it would take for Cuddles to be equal, either one of them would be consuming 1900 calories after 7 days. All right, last but not least, sometimes we get to a point where there is so much information in a problem that it is helpful to organize it into a table. So we're going to take a look at the problem on page 51 to get an idea of when this would be useful. Okay, in problem number 9 on page 51, it says Lisa is 10 centimeters taller than her friend Ian. Ian is 14 centimeters taller than Jim, and every month their heights increase by 2 centimeters. In 7 months, the sum of Ian's and Jim's heights will be 170 centimeters more than Lisa's height. How tall is Ian now? So if we read this just at the surface level, we see that there are 3 people that they're giving us information about. And at this point, if we try to do 3 different variables, that's a situation we're not quite ready for. So we want to focus in on what is the question asking. In the very end, they just want to know how tall is Ian now? So that needs to be your variable of focus. And now if you reread the first 2 sentences, you're going to realize that Ian is mentioned in both. Lisa is 10 centimeters taller than her friend Ian. Ian is 14 centimeters taller than Jim. So what I've done is I've made a table containing Lisa, Ian, and Jim. And we are going to use Ian as our variable because that's what we are asked to solve for at the end of this problem is how many centimeters tall is Ian? So Ian is going to become my x. And I'm going to relate Lisa and Jim to him. Lisa is 10 centimeters taller than Ian. So therefore Lisa would be x plus 10. And then it says Ian is 14 centimeters taller than Jim. So that means Jim is Ian's height minus 14 centimeters, or x minus 14. So this is a great start because now we have one variable all connected to Ian. But then what they mention in the rest of the problem doesn't talk about what their heights are now. It's their heights 7 months later. So they tell us they're increasing by 2 centimeters a month. So what we have to be smart enough to deduce from that is that 7 months later, 2 centimeters per month, all of them are going to be 14 centimeters taller than they were at this point. So we're going to make another column in our table and add 14 centimeters to everyone. So if we add 14 to x plus 10, we're going to be at x plus 24. Ian would be x plus 14. And if we add 14 to Jim's expression here, Jim is just going to be at x because the minus 14 added 14 to it would just be x. So now we can finish up and set up an equation because it says in 7 months, so we want to focus on this column of the table, the sum of Ian and Jim's height will be 170 more than Lisa's. Okay, so the sum of Ian and Jim would look like this. X plus 14 would be Ian, plus Jim would be X, and we know that that is 170 centimeters taller than Lisa, who is at X plus 24. So solving from here, we're going to combine like terms and get 2x plus 14. We're going to combine the 170 and the 24 and get x plus 194. We're going to get our x's on the same side, so I'm going to subtract x on both sides, leaving x plus 14 equals 194. And then we're going to subtract 14 on each side to get x equals 180 centimeters. And because the question was how tall is Ian now, and our table shows that x is what Ian's current height was, we have solved the equation and we know that Ian was 180 centimeters tall. So that is lesson 2.2. Hope that helps everybody with homework. Thanks a lot.